Well, hi, good morning. It's December 2nd here today, and the last video I encountered a situation which suggested that the broadcast band is no longer working in this radio. I got that impression by having the radio on that band and touching the antenna and just nothing happening, no extra anything. So I'm going to start right there. I'm going to guess it's just an anomaly, something I wasn't doing right, something harmless, or nothing at all. So let's put this guy on. And it's too bad it's so bright up in here. It kind of makes it difficult to get the camera to show it, but that won't matter. Okay, so we're on the broadcast band. A tune, well, for sure it's picking up stuff. Touch the antenna. Nothing happens. So this is the part that's a little weird. So I have an outdoor antenna here available. I'm just going to hook up the one lead from it. Nothing. Okay, there's definitely strangeness here. ADC on. CW off, noise limiter off, sensitivity max. Is it the band switch? That doesn't seem to be. Next band. It's the same thing. What's happening here? Next band. Nothing's getting through on this antenna. What is happening? Now I had this radio working from the antenna. Didn't I put the didn't I put the loop antenna on and tune something in with this radio? Here comes my cat. That's a little odd. Yeah, I hear you. Let's go another band. Well, that almost suggests the first tube is not tubing. Definitely a very strange situation here. Let's check that first tube. I think that's really where we got to start here. It's very odd, but I've had it happen before. Oh, the tube is plenty hot. It's definitely warming up. 6SG7. Oh my gosh, Peanut. What is the story there, cat? 6SG7. Now I'm just going to take a quick peek here to ensure. Yeah, hang on, Peanut. Oh my gosh, listen to him. 6SG7 is the correct tube for sure. I'll have to test this tube, but first I have to attend to my cat already. Peanut? Okay, my cat's all happy now. 6J5. I've got this set up. 6.3. Signal level 2, 18H, 27305, 27305, 0610, 0610, 28F. Right on. There we go. Oh! Why did I set up a 6J5 when this is a 6SG7? Wow, it's a good thing I double check stuff, that's for sure. 6SG. 6SG. There we are. Okay, once again, 6.3, signal level 2, bias 10L. Numbers are 2715K, 2715K. 4630, 4630, 29. C. Okay, we're ready to go this time. 6SG7. 6SG7. There we go. Okay. The lighting looks a little odd. This is the only way I can light this so that you can see the scale on the camera. It's actually very dark, although you know the camera compensates for everything, so it doesn't look so dark in the camera. But okay, any shorts in this tube? No shorts. Okay, so this guy would test good at. We have to do 2 tests. Excuse me, 2 tests on it. 1380, so up around here. Here we go. How do you like that? K1, K2. Test again. Wow, tests good. This isn't the problem. That's for sure. Not the problem. That guy's the problem. The radio is the problem. Boy, oh boy. What to do with that? First thing I have to do is turn the lights back on in my shop here. I have an automatic light over my bench which cannot be turned off. It's designed so you turn it off, you leave the room. That's what most people do, right? You turn the light off, you leave the room. If you don't leave the room, the light comes back on in about 5 seconds. So I cannot darken my shop without unplugging that light. It's just part of a long story of my wife and I automating our lights in our house, and it's just been, well, it's been a ridiculous disaster. That's about the best way to describe it. Now it's so difficult to turn the lights on in our house. You know. Okay, we'll go into that. Well, no signal getting through, apparently on any band. So the suspicion right away is I moved up somewhere up in this starting area. I can't believe this has happened, really. I think I want to put a signal generator on this and kind of really convince myself it's not working. Although I'm really quite convinced. Let's do another convincing thing with an antenna here. First of all, what's on this antenna? Oops. Do you have another radio? Easy. Something going on there. That's it. This is 5980 kilohertz here. Let's go 15,000. Now, shortwave reception has been terrible the last 5 days or so. It's just been terrible. Now, clearly there's something here. Okay, I'd expect the same response out of the big radio. Out of the big radio. Let's turn it back on. The plug. There's no tubes missing. Done that before. Okay, power is on. And the radio is on. Wow. Okay, that really sounds like a ordinary radio. No antenna. So I'm on band 4. I'm on the high frequency band. I'm up at 21 megahertz. It's responding to something. And there's that dirt in the capacitor I still haven't dealt with. But no effect from the antenna. Oh, there's something now. Okay, this band is so high, it's just kind of crazy to even try to pick up something with it. Go down around. This is, oh. Sounds like it's still working. Below, right around 15. right, you can't see it on the dial, but it's right where obviously the capacitor's got a bit of trouble. So it's picking stuff up. Okay, what's the problem? We'll go back to, let's just do each band quickly. I'm going to clip the antenna on here. Well, it certainly sounds like it's receiving stuff.
It is also the operating power.
Yeah, that's power, all right. Yeah, for sure this is working. It's a little odd. CW is off. Band 2, about 4.8 megacycles. There is a strong station there. Listen to the heterodyne. I think there's an oscillation in the radio there. There's definitely something weird going on there. I really wouldn't expect anything up down there at this time of day, but no, broadcast band. Got the heterodyne there. Definitely something not right with the broadcast band. Yikes. The other bands work, whether good or bad, I'm not sure yet. Maybe there's alignment issues in this radio that still need to be corrected. What's the problem with the AM band? I was quite certain I picked something up using the loop antenna, excuse me. Let's try this. Is it completely dead or is it just very, very weak? It sounds like it picks stuff up as you tune. So I'm going to feed in the signal here. Okay, we'll feed in 800. 800 moderate signal. So the radio should certainly pick this up. 800. Right here. Heterodyne like crazy. So this is dialed up to 8. Where is it? So this is a moderate signal. We'll give it a really strong signal for an antenna. Wow. 730. That could be what the radio's tuned to. But I would think the signal's getting in there and not through the antenna connection. Well, it is. But it's so weak. We gotta track this down. Okay. I'm gonna put this back on here. Want this back to one level, even though we can't hear it. How to proceed with this? I think signal tracing would be the way to do it. We're on the broadcast band. I have a tracer that will work in this band. I think that's what we got to do. So we're going to switch this guy on. And I have to look at the schematic, figure out, well, I guess maybe the grid of the first tube. We can look at the grid of the first tube. If, and the radio's still on, Jim, don't forget that. The grid of the first tube, I should be able to feed a signal right into the grid of the first tube, which should come screaming out of the radio. Either way I want to do this. Let me signal trace. Let me just take a minute to get things sorted out here. Okay, here we go. Signal tracer here is set to tune to 700. What happened there? 700 kilohertz. That's the signal coming out of the signal generator, which is running at 730 in that range. Here it is. We hear it. Not very loud. Here we are. Okay, now we just got to trace it through the radio. The first tube is right here, and it's pin 4 is the grid. Yeah, the radio turned down at the moment. Pin 4. This is the one where I buried the nubbin, the key on the tube. Yikes. Well, everything's really buried in there. Pin 4 is the grid, pin 8 is the plate. Pin 4 is the grid. And I can't see it here. So I got. To deduce where it is. So a lot of these tubes, the first two pins are stuck together. I can kind of see that under here. This would be 3, and that would be 4. So this would be 4 here. Kind of hear it. And if I touch the grid, we should hear a lot. Hear a little bit coming out of the radio. Not much. Go on the it's quiet. Tune this big radio here. Okay, so that's what's getting to the grid. This is what's coming in the radio. This is what's getting to the grid. A little louder. Now the plate, pin number 8, I think, wow, I don't know about sticking this onto a plate. I think it's designed for it. So this, inside here is a tube. There's a tube inside. There's a tube inside the tube here. Yeah, this actually gets warm after a while. And the grid of the tube is just produced out here. This is the grid. If I want to check for a signal, I think I really do need a capacitor sticking out there. I feel better. I feel better. There's something going on here. There's something going on. Not sure what that was. This will be awkward. Okay, hand on the volume control and going for what I believe is pin number 8 right here. Boom. Jeez. And on the volume. Volume right up. Nothing coming out of it, so it appears, from that somewhat terrible attempt to hear it. Nothing coming out of this tube. So I would have to guess I have messed up here somehow with these capacitors. Okay, so I'm going to stop and kind of review carefully what I've done here. Careful as I am to not make mistakes. I seem to manage to do it with some regularity. Okay, I'll check those out. Okay, so I've checked the components around here. Everything's hunky-dory, and I've also checked the resistances of this tube socket. They all match the diagram. I'm down to testing voltages here. Let's turn the set on. Give it a moment. So let's see. First voltage is worth reading. It's pin number 6, 100 volts. Pin number 8, 245 volts. 6 and 8 are the high voltage ones. Okay, let's see what we get here. So, pin number 8, so this is supposed to be 245. Oh, that's a little odd. Oh, it's not so odd. It's not so odd. I don't have, whoa, flying clip lead. I don't have the clip lead on. That explains that, I think. Okay, now we're ready. Try again. Pin number 8. Well, 260 there, and this pin here, 100. The numbers are supposed to be 102 and 245. So the voltages are there. Everything is correct. Why am I not getting any... Why is this happening? Am I just kooky and there's nothing wrong here? And I'm just fishing for something that's not in the pond? Wow, that's hard to believe because I still have, let's just do this again. I have to set on. We're on band 1. It's just hard to believe that nothing happens. I gotta short this right out to ground. Nothing. You know, this starts looking like an open coil here. Let's go up a band. Just need reassurance. I can hear that. And if I ground it out, it doesn't do much. It's a bad clip lead. Is that possible? Everything is possible. Good. No, it's not a bad clip lead. So I can short out the antenna, but everything keeps working. We're on another band now too. Very hard to hear that. Let's go up another band. Ooh, why so quiet? Something's not right. But this should make a big difference. The radio should just go from silence to screaming. What could possibly be the problem? Let me take the link out here. so far. Go on the other. Nothing happening. So it kind of looks like this problem is across all bands now. Getting mixed signals here. What could it be that would cause this? Oh my gosh, could be all kinds of stuff. I don't have this in the shorted spot. Yeah, in picking up stations. This is weird. Okay, this is being picked up with 0 antenna connected. I will now put a short on the antenna. Wow, this is a very sensitive radio if it can pick up a signal with 0 antenna and a ground on the antenna. Means it's picking it up in here somewhere. I've been fooled the whole time into thinking the front end was operating when it wasn't. Though that's the conclusion I could come to. It's way beyond an alignment problem. I think I'm going to have to prove out the circuit between the antenna connection and the grid of this tube and see what we can figure out from that. Okay, power off here. Okay, so I got to study the schematic and come up with a testing program to work my way from the antenna terminal to the first grid. First grid seems to be operating. Tube seems to be operating. Okay, and I'm going to drink coffee while I do that. Okay, first test is pretty easy. All I got to do is connect my ohm meter across the A1, A2 connections here with the link open. And I should be looking at the resistance of each of these coils. And as I change the switch, the band switch, we just test one coil after another, and we should see a short circuit or something nearly so with each one of them. And that sounds like a pretty easy test to do, so I'm going to do it. I'm going to go there, and we need this on. Put it on 600 ohms. Grab the other meter lead. Okay, first, if I short them together, we get ooh, that's not good. Who's acting up here? Maybe this lead is bad. No. What's happening there? Okay, put the meter back on. Okay, one ohm, close enough for what I'm doing. We're on. Oops, no we're not. There we are. Okay, so that's one coil. Another coil, exactly the same reading. That's a little, oh, there we are, something a little different. 27 ohms. It's quite reasonable. Go in between here. No, I can't. .4 ohms. Well, that seems like that proves these coils are continuous. So I'm the next thing I would want to do is, this is the primary side of a transformer. So I've done the primary sides, I need to do the secondary sides. And that would probably be simply by hooking up just past this grid resistor and the other terminal. Somehow I've got to find this spot. Uh-oh, with a 100K resistor there. That is probably going to be pretty difficult. Okay, so this has to be the set of coils here. And you know what I see back down in there? I see, please don't tell me that there's a wax capacitor way down in there. Oh yes, there is. Way in behind there. Oh, son of a gun. Son of a gun. That power's off. It's way back in there. Is there any others like that? Well, it's a little premature to blame something on this wax capacitor. The wax capacitor appears to be connected to the frame of the tuning capacitor. How's that help? And then I think the other lead is coming here. How's that help out? Well, that was shorted. That would do the trick, I think. The capacitor, well, son of a gun, I didn't notice this before. Capacitor is insulated from the chassis. It's just a little subtle to spot it. So the frame of the capacitor is grounded through a capacitor. The frame of the tuning capacitor is grounded, or something's done with it, to this point. Now what is this? This seems to go all over the place, so this is probably a ground point. Let's see what Mr. Meter says about that. Shorted to ground here. Like this is not a ground point. Or is there something more going on? I'm on resistance, but the test seems futile. Okay, we check the capacitor frame. I can't see the meter. It's definitely isolated. What is that capacitor doing there? Let's take a look. Okay, so if we look at the tuning capacitor, it's shown here. Frame is grounded. Oh. Maybe I'm not looking at this right. This might indicate the rotor and the frame is shown grounded here. There's no capacitor. This is the number 80 schematic. Yeah, let's look at the other schematic here. Somewhere I can find it. Here it is. So again, we're looking here. The frame of the tuning capacitor shown grounded. That's right, but that capacitor I saw is not going to ground. It's going somewhere else. So that means the frame of the capacitor is. Why would they isolate it? And then put a capacitor to ground. This is how it's shown here. What's happening? They're showing something else a little odd here. What's going on here and here? At a glance, I figure the tuning capacitor and its trimmer, but look, they're shown tied together. And there should be another capacitor. Here it is down here. A solid ground. This is another fine mess I find myself in. Schematics that don't seem to match. Let's check this frame again and see if it isn't solidly grounded as it's shown here. Wow. I'm waiting for something to jump out at me, but I don't think it's going to. Okay. Okay, what's going on? The mystery is getting more mystifying. Okay. This lead on the ground. This lead on the capacitor. Oh, it shows it is grounded. So the capacitor, you can think of it as coming from here, and it's maybe I'm just not seeing this right. Maybe that's what's going on. I'm not seeing it right. So I can see the lead from the capacitor going into a black tube covering, going through a hole in the chassis, coming up here. There it is. And there it is. I mean, how can I not be seeing this for what it is? Now, this frame is just intimately connected to the stators. I'm sorry, to the rotors. Yeah, there's some dirt in here too. So, what's happening here with this capacitor then? But why did they bother with these grommets? Now, it's in some radios, I think they're allowing for a little bit of shifting of the capacitor. They put some grommets in to allow it to shift. But I don't think that's the case here. They're trying to isolate it. But it's not isolated. Oh, that's right. The schematic, the additional, the double thing here is the band spread part, band spread tuning. Now, I see something back here. Let's take a closer look at that. Where's my camera? Camera's way over here. So you can see the screw going through a grommet into the chassis, and then there's a copper band and a lug. There's this piece of wire, carefully covered. Appears to be involved there. Hard to say. So what's going on underneath? So we find that screw underneath, if we can find it. It's down in here somewhere. The power is off. Okay, let me just get my finger on it. I find when I gotta locate these things, if I put my finger on the top, I can kind of tell where I should be looking. So I should be looking down in there. Oh my gosh, there's just so much stuff. How are we ever going to see in there? The other thing that sometimes happens is these capacitors are grounded in one place only. What is happening? What is happening? Maybe that lug is grounded. Why would they have a wire coming to the lug if the lug is floating entirely? So again, that would be on the frame to the chassis. So it shows as it's grounded. So I'm going to guess that's what that is. It's not making a lot of sense here. Yeah, it's 0 for sure. And then why would you bother putting a capacitor there? Like, the capacitor's under here. Why put the grounded lead up through and onto there if the chassis is purposefully grounded? The other lead from the capacitor, it definitely comes to this terminal. This terminal is not grounded, so that would mean no short in that capacitor. That's one side of the capacitor, and this is the other. Oh. So yeah, I'm looking across the capacitor now. No short. If I put this on ground, it's not making sense to me. It's short. Am I looking right at the problem? Is this the cause of the problem right here? The schematic shows the frame grounded. It shows it grounded all over the place on the schematic. Now, they kind of have to do that on the schematic because they got to explain where things are going. It doesn't mean there's multiple grounding points. The capacitor's coming from here. No, I don't know, this is probably one band, another band, a third band. Where's the fourth? There's two up here every time. 1, 2. I don't know what's going on. I haven't got to that point yet. Can we identify what this is? Well, this is coming right off the A2 lead, straight onto here. So if we look and we go A2, so this is A2 would be, if they follow the look of it, it's this middle one. It's this one, it goes right onto the coils. My head is going to pieces here. Is that the capacitor right there? Shows it coming from the primary side, a secondary side. That's what this could be. This could be that capacitor. 0.05, so it's the right value, kind of value. Doesn't seem to be anything wrong with that capacitor. How would that, if that were open circuited, no capacitance, why would that throw this radio way off? I don't think it would. A little leaky? I don't think that's going to throw anything way off. It's only attached. No, it's attached to this line, so it's active the whole time from any band. You know, 0.05, I don't think it's an integral part of the tuning of this at all. It's trying to just provide a signal ground. And for some reason they've chosen to feed it up through the chassis and attach it quite firmly to the case of the frame of the tuning capacitor. Well, where do you go from here? There's a 100K resistor here. Oh my gosh, I don't know what's going on. What's going on? I don't know. Well, I have not managed to prove these coils, but they'd all have to be open to give this kind of effect. The secondary side, they all have to be open. But the radio does respond a bit when you touch the antenna, but that could be simply because we're just introducing more signal kind of generally into the radio, and it's being picked up by sensitive circuits here. So there's a gain value for that tube. The gain RF grid to converter grid. So that's the RF to, the gain is 2. Antenna to the RF grid, and that's talking about these transformers, the gain is 4. We did kind of notice an increase in the signal strength. What am I chasing here? We have another whole set of coils before you get to the converter grid. Oh my gosh, I don't know. I'm really stuck here. I'm really stumped. I'm sit and stare at that for a lot. I think that's what I'm going to have to do. Slow video. I'm heading back to step number 1, which is feed in a known signal at the antenna. Check what kind of sensitivity is in this radio. Okay, so we've got 730 on here. And we have a... Oh, let me check the calibration here. That's right on. We have a modulated, strong enough signal that any radio would pick it up, fed into the antenna this way. And we want to go band 1. Can we find it? It's got that heterodyne happening there. So 7 would be right up around here. Something's not right. Okay, so we'll put this around 750, and we'll find it this way. Oh my gosh. Okay, so I'm pumping it's blasting a heck of a signal into the radio. We're grounded here. This is the right lead. It's going in there. It's going into A1. And getting almost nothing through the radio. For all I know, the input signal is so strong it's skipping the problem and getting into the radio in a later stage and coming out. Because that should just be screaming out of this radio, and there's almost nothing there. Let's go band by band. We'll go up another band here. So 2.4 megahertz. Sounds like a radio. Fairly low signal. So I'm going to buy it. That's right. This is on 2. 2.4. 2.4. I didn't hear anything. This is getting more unnerving. If I'm not better. Let's give it a blasto. There it is. Okay, so only a terrible radio requires that kind of signal strength to make this kind of noise. Something is seriously wrong here. Let's go another band. Let's see, I'm going to turn this up quite loud to hear anything. So now we're at 7.5. That's a little more normal. So now we're looking at a weak signal. A relatively weak signal. Most good radios would be able to receive this, maybe like we hear it. It's heterodyne in there again. So really, let me just check calibration here. That's, that's better. That's kind of within the range of what this radio should be doing. top band. We're now up around 21. Okay, so that's acceptable. So what have I found here? 2 bands that are bad. So with this signal level we're hearing now, listen to the thing. Sounds like it's as happy as can be. Back down to 2.4. And there's just nothing there. So that went up 100 times. It's 100 times stronger signal to get the same kind of response, the same kind of output. Okay, leaving the signal at this strength, we're now on close to 8. Listen to that. The heterodyne's worse. We're looking at 8. Barely hear it. That's a really strong signal. So is this thing just getting worse as you go up, as you come down? Or is it 2 bands are in trouble and 2 are fine? Yeah, that's a good question. Could it be alignment? I can't believe it'd be that bad. I mean, the IF alignment was very good. There's really no reason to think these are out of whack if the IF is not. The fiddlers tend to fiddle with the IF transformers maybe without knowing what they were doing. Did that when I was a kid a lot. Got a lot of radios to make a lot of funny sounds. I didn't really understand what I was up to. I don't think that's what's happened here. I think this radio's in good shape. Wow. Well, I'm just going to have to tone out his signal all the way through, step by step by step by step. Okay, so if we take this strong signal, let me turn on my signal tracer again. We're back around 700. Okay, I've got a clip lead, please. Okay, let me just check this quickly. Yeah. This is the ground connection. Okay. Now we'll pick it up with this. Starting right at the antenna. Look at, you just have to get near it. That's good. Let's stick with that. We're following this wire back here. And we're coming up to the grid. I don't hear anything. What happened to it? Not tuned in. Not tuned in. Can we even... Okay, I don't like having my hand on the chassis, but... No, it's not doing anything. Definitely band 1. Definitely tuned right around 800 is where the... Should be down in this area. But, oh. That's with a whopper of a signal going in. So if we go on the grid, which was what pin? What pin was the grid? Pin, I cannot remember. You just have to repeat this again. 6 SG7 until I discover what is going on. This is quite disappointing. 6 SG7. The grid is pin number 4. pin number 4, the very powerful signal. Grid number 4, 1, 2, 3, this is 4. Wow! Ooh, yeah. Let me turn this down now. There's lots of signal there. Lots of signal there. Let's say that again. Don't do that. Lots of signal there coming out of that tube. Okay, so now we've made it through the secondary side of those, of at least one transformer. Oh, my book is coming apart here. I should leave it open. 6SG. No, yeah, 6SG. S6S. Spell, man. 6SG is 8. So we should have an even stronger signal on pin number 8. Pin number 8 is right there. The hand on the volume control. So this is what's hitting the grid. 1, 2, 3 for this here. That's the grid without changing volume. Be a big pop here maybe. Whoa, how come that happened? Well, where'd that come from? This guy's sparking like that. Still working, or did I kill it? Okay, I skipped the capacitor and see what happened there. Exciting moment. Got a bigger antenna now. Okay, hand on the volume. Nothing. Is that not 8? Is that not pin 8? Is that not pin 8? Okay, double check everything. Here we go again. 6SG7. Pin number 8 is the plate. Has a P right beside it. There's no question about that. Now, is that really pin 8 I'm looking at? Or did I pick the wrong pin? Well, if it's pin 8, it's got a big voltage on it. That has to be pin 8. Can there be a secret pin 8? Can I read the numbers on the socket? That might be pin 7. Well, where would pin 8 be? Pin 8 would be just buried. Nah, I don't think so. I really don't think so. Okay, pin 8. Prove it by looking for the B plus on it. Look for the B plus. B plus on what I think is pin 8. Ground. DC. I think this is pin 8. Yeah, look at that. Only one reason there's 260 volts there. There's no amplification through that tube. But I've tested the tube. Is it the wrong tube? Can't be the wrong tube. How can this be? There was a tube mix-up in this radio. 6SG7. Some of the tubes are labeled on the frame. Let's take a look at that. Okay, we're going to cut the power here. And I'm going to try to find out. I got the tubes mixed up. See here. 6SG7. Right there. Hot as can be. Why so hot? It could just be because. No reason beyond because. 6SG. I'm looking for some cloth here. Just grab onto that too. Well, do I have to grab onto it? Can I just read it? Can I just read it? Read it with... read it with my mirror. Where is the mirror? Arr. I mean, I've had this tube out in my hand a couple times. Is it still too hot? SG7. That is a G. That's not a Q. This was in the 6SQ spot. Well, is it possible? No, this can't be. I tested it as a 6SG7. It's got to be a G. There's no way. There's no way that G is really a Q. It's the right tube in the right socket, and the tube works. There's no output on the far side. No output on the far side. Lots of signal on the grid. Nothing on the far side. How do you achieve that situation? You have open or incorrect bias. Open cathode. Open cathode. Open cathode circuit. Take a look at the cathode circuit. There's a resistor there. And then it comes all the way down. Oh, it comes down into this guy. This is this guy. You should be able to go on the cathode and see a resistance of, I checked the resistances. 120 ohms. Cathode is pin 3 or pin 5. Pin 3 or pin 5. Set is turned off. Pin 3 or pin 5, your choice. So pin 3. Am I doing this right? This would be 3 here. 134. Did I just do that right? Pin 3. That's a voltage table. 140 ohms. I've done these over. Pin 5, same reading. I've done it. It gets the same reading. The only pin that's a little bit out is pin 8. It's supposed to be 20K ohms. 20,000 ohms. Yeah, 20,000 ohms on pin number 8. Yeah, gotta be 8. Pin number 8. I thought 8 was the plate on that too. 6SG. I was working in my job just after I started working, after I finished with college and started working in my career job. Maybe there for a year, and a guy came in and said, "Hey Jim, maybe you'd like this book," and he handed me this. And this is probably the book I've used the most in my life since then. Unfortunately, the cover's wearing out. Look, he had himself drilled holes and put this string in. I'm pretty sure he did that to further bind it. But I have worn it out. His name was Hugo Oja. Thank you, Hugo. He's been dead for decades. 6, so, okay, enough of that nonsense. We're looking for a 6SG7. Can't remember at all what I'm doing, so I've been in here too long. Remote cutoff pinto. Yeah, I'm dealing with the idea that the bias is way off, or the cathode's open. That's what I'm looking at. So the plate, but if it were open, we'll stop talking. Plate, pin 8. And pin 8 is supposed to give us 20,000 ohms. Pin 8, 20,000 ohms. Pin 8. So we're going to 25. That's just a resistor going high, I'm pretty sure. There's a resistor right here. $20 to $25, that's not going to do this. That is not going to do this. Problem. What if the resistor's not high and there's something more in the circuit? Something else is not working right. So we measured here. There's a 27 ohm resistor. It goes into all these coils. B plus would come up through here. I checked the voltage and the resistance just with it sitting on one band. I didn't switch through the bands. It is on the band in question right now. Let me clip the ohm meter and then I'm going to call it quits. We're going to do this last thing. I'm calling it quits for today. Take this guy. So we're going on the plate. Supposed to see 20, tend to see 25. Let's just switch through these. That's quite a bit more. And they're all there. 25. 25. Those are the two bands that work. 30. Back to 25. What's happening with that? You would think as I go up in bands or whatever, if the resistance was changing, it would be going down, 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 or up, up, up. It wouldn't do a whoop-de-doo in there, especially when the circuit is like this. Hey, what's that? Got a situation here with, hey, where's the primary on that? Okay, that's a little odd. So there's a variation in how these work. But why am I worried about these? Because I'm measuring on the plate, and the plate is going through them. There isn't one here. So you get a very different reading there. What are they doing about putting a primary here? There's something more going on. Yeah, wow, okay, that's another weirdness. Now the switch is broken. And the switch be so dirty it's interfering consistently. There's never a time where this works. That's a fat chance thing. Switches are usually, you know, you can wiggle them around and they make and break contact. Oh my gosh. I am stumpified here. Yeah, I did say I was going to stop. I got to stop. I got to force myself to stop. I could do this all day. It wouldn't go over well. Okay. That's it. I am stopping stumped. I'm stumped.